but Jeremy will be presenting today. I'd like to recognize Mr. Richard Mooney for coming in and helping me help Jeremy much of the semester here and collaborating on this team. So, you'll set. Let's get this.
Welcome everyone. My name is Jeremy Zavantes. I'm a senior computer engineer, and my senior design project is building the battle bots with the mechanical engineers. So quickly, we're just going to go to a complete outline of what exactly the battle bots is going to be, and all the programming that I'm going to cover up, and all the electrical components that I'm going to be covering up as well. So what is basically BattleBots? BattleBots is basically a national televised programming competition where we introduce mechanical remote control robots and we use these robots to fight against one another in combat. So what we are technically designing is what we call a drum bot, and the drum bot here is a more destructive sort of bot where we have the motors. The motor here is displayed as like to spin, and as the drum motor increases its spinning, it'll be able to crush any other bots or any other things that's coming in its way. The backside down here would be the batteries to power up each of the motors, and these two motors on here are the drive motors to help power up on the wheels. The top motor is the drum motor that represents on like powering up on the drum side, with using the sprockets to help steer the wheel. My project motivational here is to help develop a collaboration with the mechies. I'm hoping that we will be able to work together and be able to finish up on this project together, being able to have a competitive robot and hopefully it works to make sure that it's going to be able to run and be able to fight against any other robots. And our main goal here is to ensure just the survival and the intelligence of this whole project, making sure that the safety of our teams and as well as the bot itself, making sure that it doesn't catch on fire, making sure that there's nothing wrong with the controllings or focusing on any other injuries whatsoever. Main focus on the objective, I'm mostly here to just program on the Arduino or how to make sure that the controls will be working with it in terms of using the right receivers to see if it has enough frequencies to run with the RC controllers, and making sure that it can run on the battery and to power up on the robot. And for the mechanical engineers, they will be building the bot itself to making sure that the motors are right in place and to make sure that it's built firmly inside the robot. As you can see here on this design port, you will have the receiver. The receiver will have enough frequency to make sure that the controllers are ready and set to have the batteries powered up. And then with that battery, it's just going to have enough power to drive on each of the motors to the sides. And then it's just going to have like the each of these electronics on the drives and the drums will be able to help steers on both the drums and the drive motors. And as you can see here, I have designed this H-bridge. It looks kind of messy, but when you see here, by using the pulse width modulation on this side here on speed controlling, we will be able to give out a certain square wave signal from the oscilloscope, and it will give out a signal from 0 volts to 24 volts. And as a result, it will help give out a bidirectional motor speed controller. So if you see from the directional drives on here, if we're able to have a switch, the switch will be able to turn one side of each side of the H-bridge and be able to make sure it drives one side of the motor or the other. And if both switches turn on, then suddenly the board will just suddenly pop out and then it will just suddenly combust, and we won't want that to happen. The requirements for here. So the requirements for the rules of the BattleBots competition, we want to make sure that the bot is able to run at a fast pace of 4 miles per hour or more, and to make sure that it's enough to at least move forward or move back faster enough to withstand any other bots. And since it is a drum motor, it is very strong, it's very sturdy, so it's going to have a huge rotating mass in the front because of the drum motor. The drum motor is sturdy and strong and is being able to compact with any other things. We surely want to make sure that we want to have a strong bot to make sure it's crazy enough to have all the materials ready to fight other bots, or like if it's going to damage the bot itself. And because the bot is sturdy, has a sturdy frame, it's able to take any other hits that's going against from another bot. And during our calculations, we have decided, since the rules has said to have a maximum requirement of 48 volts, we decided to have our volt cut in half to have about 24 volts. So that way we don't set any injuries to the bot or to ourselves, because if we exceed more than 48 volts, then the bot is just going to explode and we're not sure if we're going to be able to run it properly. This is our system description of how we have the materials ready for all the electrical components. Here is what we see our transistor. The transistor here is called the Infineon. The Infineon here is an N-channel transistor polarity with 3 input pins, the drain current being at 29 amps, and our threshold will be at about 4 volts. So it helps to create a conducting part between the source and the drain terminals. So our key module here is for powering up our BattleBot is the use of the Arduino, and what we have here is the Arduino Uno R3. Which has about 14 digital inputs and output pins, half of them being pulse width modulation outputs with 6 analog inputs, a USB port connection, a power jacks, and a reset button in case any precautions were to happen. And the requirements using for these Arduinos is to have our pulse width modulation set at 3, so that way we can have for each of the speed controllers, since we only have 3 for each. Our output source is going to be 3, as well as to help with our forward and reverse switches on setting up the directional drives for both the wheels. And our digital inputs will be up to 2 to 4 PSI interfaces to the receivers, as well as having inputs of 1 for our battery voltage. For our risk analysis, we have a few questions to say. So like, what if the controller doesn't seem to work on the Arduino, or what if the bot just spontaneously combusts in the middle of a competition? So because it is a drum motor, and due to the heavy mass of the rotating at a high rate per minute, the bot can be difficult to control. So it's going to be hard to move the bot because the motor is just driving us very fast or at a very high speed. So we want to make sure that the direction of the motor is at a right pace, and making sure that it's able to drive smoothly. And with a high moment of inertia, it'll make sure that the bot it's going to make sure that the bot is going to flip over as it turns. So we don't want that to happen. We want to make sure that it glides through to one side and the other, and make sure that there's no moment where it's going to end up flipping backwards and then it's not going to be able to turn or move back. So for our test planning, as soon as we are done making our designing, once we hit the test planning, we would make sure we want the programming to be done. We want to make sure to power up, to have the right receivers, to have a good connection to the controllers. As you see here, this is an example of what kind of controller we're going to be using for our Arduino to have it power up on the motor bot. See here, we've got an example of a Xbox controller. This Xbox controller will have the amount of the motor, the direction of the motor, the speed of the motor, and as well as having all of the pulse width modulation set up into it, so that way it can power up with the Arduino bot. And here's just the basic materials on all of the electrical components that we just need. What we mostly need is just an RC controller of an Xbox controller, or if else goes wrong, we can just use a normal RC controller known as the Skyfly 04. The Arduino board is just a simple Arduino board. Then we'll be needing 4 different types of batteries. We have discussed it. We ended up finding out online saying that if the Zippy 5000 and the Bolt 3400 would be the right component, with the Zippy 5000 being the drive motors and the Bolt 3400 will be for the drum motors. And our speed controllers will we'll be using 3 of these each for each of the drive motors and drums. Our project planning, we are nearby done with the projects. We're slightly behind on the electrical components, but I will get right to it right now or as soon as the semester ends. And we will be completing our design project around December 30th. And right as soon as we hit January 1st, we will begin to build the project as well as begin to programming the actual Arduino to the bot. Because of all of the materials that we need, including the mechanical parts, our total estimate cost will include up to about $2,000. Our project budget will also end up being about $2,500 as well. It's kind of expensive, but we will get right into it. And to end us with a summary, we just have our drum designs and our drive designs for each of the motors having a certain amp flow to it. And with the right calculations, we had enough to determine the amount of torque, the amount of watts, the revolutions per minute, and having our shaft designs with all how our gearings and mounting will be on how to input each of these motors into the bot. And that's it.
Any questions?
Yes.